Logistic regression is a powerful machine learning algorithm for classification tasks. It is easy to understand and implement, and it can achieve high accuracy on many real-world problems. Logistic regression is a supervised machine learning algorithm used for classification tasks. It predicts the probability of a binary outcome, such as yes or no, true or false, or 0 or 1. Hi everyone, and welcome to Learn to Profit. Today, we're talking about logistic regression, one of the most popular machine learning algorithms for classification tasks. In this video, we'll cover everything you need to know about logistic regression, from scratch to professional level. We'll start by discussing the basics of logistic regression, such as what it is, how it works, and when to use it. Then, we'll dive into more advanced topics, such as how to train and evaluate a logistic regression model, and how to interpret the results. What is logistic regression? Logistic regression is a supervised machine learning algorithm, which means that it learns from labeled data. The data is labeled with the known outcomes, and the algorithm learns to predict those outcomes for new data. Logistic regression is used for classification tasks, which means that it predicts the probability of a binary outcome. For example, logistic regression could be used to predict the probability of a customer clicking on an ad, or the probability of a patient having a disease. What is the difference between linear regression versus logistic regression? To truly grasp logistic regression, it's essential to understand how it differs from linear regression. While linear regression predicts continuous values, logistic regression predicts probabilities and classifies data into discrete categories. How does logistic regression work? Logistic regression works by fitting a logistic function to the data. The logistic function is a sigmoid function, which means that it outputs a value between 0 and 1. The logistic function represents the probability of the binary outcome. For example, if the logistic function outputs a value of 0.7, then the probability of the outcome is 70%. When to use logistic regression? Logistic regression is a good choice for classification tasks when the data is linearly separable. This means that the data can be divided into two groups using a straight line. If the data is not linearly separable, then there are other machine learning algorithms that may be more suitable. Training and evaluating a logistic regression model. To train a logistic regression model, we need to provide it with labeled data. The model will learn the relationship between the input features and the output labels. Once the model is trained, we can evaluate its performance on a held-out test set. The held-out test set is a set of data that the model has not seen before. The performance of the model is evaluated by calculating its accuracy. Accuracy is the percentage of test examples that the model correctly predicts. Interpreting the results. Once we have trained and evaluated a logistic regression model, we can interpret the results to understand how the model is making its predictions. We can look at the coefficients of the model to see which input features are most important for predicting the outcome. We can also look at the intercept of the model to see the baseline probability of the outcome. Real-world applications. Now that you have a strong grasp of logistic regression, it's time to explore its exciting real-world applications. Logistic regression, with its ability to predict binary outcomes, finds extensive use across various domains. Here are some notable applications. Healthcare and medicine. In the medical field, logistic regression plays a critical role in disease prediction and diagnosis. It helps identify the likelihood of a patient having a particular condition based on various medical parameters, aiding doctors in making informed decisions. Finance. Logistic regression is used in credit scoring to assess the creditworthiness of individuals. It helps financial institutions determine the probability of a borrower defaulting on a loan, guiding lending decisions. Marketing and customer relationship management, CRM. Marketers employ logistic regression for customer churn prediction. By analyzing customer data, businesses can identify those at risk of leaving and implement retention strategies. Natural language processing, NLP. In sentiment analysis, logistic regression is used to classify text as positive or negative. This is valuable for businesses to gauge customer sentiment from reviews, comments, and social media posts. Image classification. In computer vision, logistic regression is used as a binary classifier for tasks like facial recognition, object detection, and more. It helps in distinguishing between different objects or characteristics in images. Sports analytics. Logistic regression is applied in sports analytics to predict game outcomes, player performance, and injury risk. Teams and sports analysts use these insights for strategy development. These are just a few examples of how logistic regression is applied in various industries. Its versatility and interpretability make it a valuable tool for solving real-world problems. If you enjoyed this video, be sure to like and subscribe to the Learn to Profit channel for more videos on machine learning, data science, and other related topics. Thanks for watching.